today we're going to be going over Section F, Trigonometry, of the West African Examination Council Senior Secondary School Certificate Examination, Mathematics for Liberian Schools. On Section F, which is Trigonometry, we're going to be going over the sine, cosines, and tangent of an acute angle. Today we're going to focus on finding the sine, cosine, and tangent of acute angles of a right triangle. You understand that when you have a right triangle, one angle is 90 degrees. That's the right angle. So the other two angles would be acute angles because they will sum up to what? Now, they are all less than 90 degrees. Good. Now, so to be able to do this, we need to have some basic theory which you went over in school. But yeah, we just want to go over it so that you have an idea of the kind of knowledge and concept you need to be able to handle problems like these. So first of all, here's a right triangle. In this right triangle, this is the right angle. So it has three sides to this right triangle. The sides A and B, we call them legs. And we call C the hypotenuse of the right triangle. Use the right triangle. Now, because I'm writing this for people to see, I'm going to clean this up. So let's go. C is the hypotenuse of the right triangle. So what is the hypotenuse? The hypotenuse is the side that is opposite the right angle. So the hypotenuse is the side that is opposite the right angle. That's very important for you to be able to recognize. Well, when it comes to A and B, you could change that. You could interchange the representation. You could represent B, A. It does not matter, they are just legs. But the hypotenuse must be the side that is opposite the right angle. Now, so let's move on. So you saw that when let me just pull everything down and then I explain it. Good. So let's look at two different cases. Let's look at the right triangle here and let's take into consideration, for example. So in a right triangle, if this angle B is a right angle, then angle A and angle C are the acute angles. So we could find the sine, cosine, and tangent of angle A. Likewise, we could find the angle sine, cosine, and tangent of angle C. So to be able to do that, we must have some very fundamental concept. One, the side opposite B is the hypotenuse. Okay? Now, in relationship to angle A, this side BC is opposite angle A, and the side AB, because they share a common point, is the adjacent side. So that's why we have AC is the hypotenuse, is opposite the right angle. BC is opposite to angle A, and AB is adjacent to angle A. It's extremely important to be able to recognize opposite, adjacent, and hypotenuse. Now, in relationship to angle C, the side opposite C is going to be AB. The hypotenuse is indeed the side opposite the right angle, and now the adjacent side to C will be BC. Very important to be able to correctly identify the opposite and the adjacent. So, here's the first rule we need to go over. It says the definition of the sine of an acute angle of a right triangle. Now, we're going to be focusing on angle A. We could do the same thing for angle B. So for angle A, we say by rule, the sine is equal to, the sine of angle A is equal to the side opposite angle A, is equal to the ratio of the side opposite angle A to the hypotenuse. So, what side is opposite angle A? This is angle A. Opposite is the side represented by small a. Where's our hypotenuse? Our hypotenuse is the angle opposite C. Big C, so it's that small c. So there's a formula for finding the sine is going to be what? A over C. Opposite over hypotenuse. Then we have the cosine. By rule, the cosine of an angle is equal to the adjacent side. That means in this case it's B over what? The hypotenuse, which is C. So it's the ratio of the adjacent side to the hypotenuse. We give you the cosine. And then we have the tangent. Basically, the tangent is the ratio of the side opposite to the adjacent side. Now, having said this, there is something we call a mnemonic, some strategy, some device, some creativity, some innovative concept that you can use to remember these formulas. Because like anyone, I know it can be extremely hard to maintain this. So we use something like this. We say so ka toa. And I'm going to explain this to you. What it means is that the sine of an angle is equal to the opposite over the hypotenuse. So this is for sine. And then it says right here, the cosine of an angle is equal to the adjacent over the hypotenuse, cosine. And then this is for the tangent. T star tangent is equal to the opposite over the adjacent. So this is tangent. So you might want, and I'm sure you've already gone over this, so once you can recall this, you can retain this, you should be able to get the formulas. And once you identify correctly the adjacent, the opposite, and the hypotenuse, you should be able to find the sine, cosine, and tangent of any right triangle, any acute angle of the right triangle. So now let's engage some problems and see how it works. So here's problem number 1, taken from the past WAEC examination for Liberia. It says, given a right triangle below, find the sine of B. So now here's our angle B. I'm going to mark it. This is B we are interested in. So let's do this in relationship to B. So we know that our angle is B. So in relationship to B, let's identify key things. Let's identify what is going to be the hypotenuse. That doesn't matter. In this case, it's going to be the side opposite the right angle. Let's see the opposite, and then let's also identify the adjacent side. So the hypotenuse is the side opposite the 90-degree angle. So in this case, it's going to be 13. The side opposite B. So here's my angle B right here. Opposite is going to be the side AC, which has a length of 5. And the adjacent side obviously will be the side CB, which has a length of 12. So what are we trying to find in this problem? They want us to find sine. Sine. So katoa, sine. Remember this from SOHCAHTOA? So that's sine. So they said the sine will be equal to the sine of what? Angle B. Will be equal to the opposite to B divided by what? The hypotenuse. So what is opposite to B? 5. What is hypotenuse? 13. So basically the sine of angle B would be the opposite, which was what? Let's go back there. The opposite was what? 5 over the hypotenuse, which was what? 13. And so this is done. Very basic, very easy, and very simple. It's a case of application. So what we're going to do is that we've been given that the tangent of a certain angle x is 3 over 4. So what we're going to do is to use our definition of tangent to construct a right triangle, and then use that right triangle to find the cosine and sine and put them in here to evaluate this. So let's go ahead and do this. So by rule, we know that tangent of any angle x, in this case, must be equal to what? Opposite over adjacent. Remember, TOA from SOHCAHTOA, tangent. So if in this problem our tangent is what? 3 over what? 4, it means the side opposite in this angle x here will be what? 3, and the side adjacent to angle x will be what? 4. So what is missing here is the hypotenuse, which we don't know. But remember, we are dealing with a right triangle. So we can, remember we are dealing with a right triangle. So we can find, okay, I see a little mistake here. I'm running a little bit ahead of myself. So maybe I'm leaking up my secret. The adjacent is what? 4. Good. So now let's draw this right triangle. Let's do this. So we're interested in finding the tangent of an acute angle x. So here's the right angle. We know that the side opposite to this right angle is 3. The side adjacent to this right angle is 4. So we don't know the side. So how can we find this? This is a right triangle, so we can apply the Pythagorean theorem on this to find the other side. So let's move and see how we do it. So, well, 3 and 4 are the legs, so I can use the Pythagorean theorem. A squared plus b squared equals to c squared. So I have the leg squared plus 4 squared. And this is a popular one. So 3 times 3 is 9, 4 times 4 is 16. That's going to give me 25, and I'll take the square root of 25 to get what? C will be equal to what? 5. So C is equal to what? This hypotenuse here is 5. So then, let's do this. So, we got to go back here, and then, because what we need to find is this. We need to find cosine squared x minus sine squared x. So we need to find the cosine and sine. So here's what we need to find. Cosine squared x minus sine squared x. So let's find the sine and cosine. So how do we do it? I would say the sine of x by rule is equal to opposite over hypotenuse. What's the opposite here? 3. What is the hypotenuse? 5. And then I will say the cosine of x is equal to adjacent over hypotenuse. What's the adjacent in this case? The adjacent here is what? 4. What's hypotenuse here? 5. So I have every information to put in here. So my sine is 3 over 5. So I'm going to go over here. It says cosine squared. What's my cosine? 4 over 5. So I'm going to do 4 over 5 squared minus, what is my sine? 3 over 5. So I do 3 over 5 squared. And what do I have? 4 squared is 16. 5 squared is 25. Minus 3 squared is what? 3 squared is what? 9 over what? 25 squared. 5 squared is 25. And what I have here is same denominator, 25. 16 minus 9 is 7. So the result we have here is what? 7 over what? 25. We are told to find the sine of this given angle. So what do we need to know? First thing, let's look at the sine of the given. Let's find the sine of P of the given triangle below. So we wanted to find the sine of angle P. So well, let's look at this. So we have angle P. So let's do this. Let's see if we know the opposite, the hypotenuse, and the adjacent in relationship to angle P. Well, the side opposite angle P is what? 6. The adjacent side to P is what? 4. So the hypotenuse is missing. Well, this is a right triangle. So again, we can find the missing side PM by using the Pythagorean theorem. So I can say side PM, which we don't know, and it's a hypotenuse squared, will be equal to OP squared plus OM squared. And this we don't know. So we say this. What is OP? OP is what? So 6 squared plus OM, which is what? 4 squared, was equal to this. So we have 6 squared is going to be 36 plus 4 squared, that's going to be 16, and it's going to give me 52. So to find PM, I must take the square root of this. So PM is equal to the square root of 52. Now, this is not a perfect square, but I can break it up into 4 and 13, because 4 times 13 is 52. And when I find the square root of 4, I'm going to get 2. So I have 2 square root of what? 13. So my side here is going to be what? 2 square root of what? 13. So that's the end. So good. So I'm finding the sine of this angle. So sine of this angle, I know, and I want to just lay it out over here. So sine of P will be equal to the side that is opposite P over the hypotenuse. So I'm going to go over there. So the side that is opposite P is actually what? 6. And the hypotenuse is what? 2 square root of 13. So let's go. So the sine of P is equal to what? 6 over what? 2 square root of what? 13. And when we divide here, we're going to have 3 over square root of what? 13. Now, the problem is that we have to rationalize. We cannot have a denominator to be a radical. So we must, to rationalize, we must multiply both numerator and denominator by this denominator. And that's going to eliminate the radical from in the denominator. Square root of 13 times square root of 13 is square root of 169, which is basically 13. So our answer will be 3 square root of what? 13 over what? 13. So that's it. So again, this is it. Find some time, go online, register on our website to be able to do some practice. Again, this has been a production of Field, the Foundation for Equity and Excellence in Education in Liberia. We are committed to providing quality content education. Please subscribe to us and support us. Go to our website at www.fieldliberia.org and be able to make a minimum contribution, some kind of contribution to help us produce more videos of this kind, which we found has been very, 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 very appreciated in Liberia. Thank you.